RSA is an asymmetric cryptography system, meaning it uses two separate keys. The public key uses both private and public, which are very different from each other. The public key can be given out freely and is distributed using two large prime numbers, though these two numbers are kept secret, while the private key is only given to the authorized individual and is for decryption. RSA is based on the factorization problem, which makes it impossible to factorize prime numbers. As you can see here in the design, the program is separated into 4 different categories. The first is key generation, which allows the user to type in their message, and it converts the message first into numbers. For example, A equals 0 and B equals 1. Then you are prompted to type in 2 prime numbers, and from that you get E, and you get the private key D, and you also get the public key E and N. Next you have the encryption, which computes C equals M to the power of E mod N, and you get the encrypted message from that. Then you get the decrypted message via the private key D, and it computes M equals C to the power of D mod N. And from that, you should be able to compare it to the key generation where you typed in the message, and it should be the same. So this is the demonstration. If I type 2, it will generate me the keys, and then it prompts me to type in a message. I'll encrypt high. That equals 78. So this basically means A equals 0 and B equals 1. So H equals 7 and I equals 8. So now I'll have to type in a prime number. I'll do 991 and 997. If I scroll up, that would say that they are actually prime numbers, and it gives me the value of E, the public key and the private key. So if I type 3 to encrypt, the encrypted message is here, and then if I decrypt it and press 4, that gives me the number 78, which if you scroll up to the first, you can see that the encrypted message is 78. So that's the demonstration. There are checks in the program. For example, if I want to encrypt high, but if I do a number that is not a prime number, for example 35 and 40, if I scroll up here, it says that 35 and 40 aren't a prime number, so I'll have to start the program again. Otherwise the result wouldn't work and the decryption would be wrong. In conclusion, we have learnt that prime numbers are a big deal as it forms the basis of RSA. The program which was coded covers the basics of the RSA algorithm. We have proven that the code works as we can encrypt and decrypt the message. The console log also displays all the needed information and variables which are present in the algorithm. However, there are some things which can be improved, for example, generating bigger prime numbers to increase security.